Today we're going to take a look at the procedures of acid-base titrations. We had already done last week, we had already done the calculations related to stoichiometry with the acid-base titration. So let's take a look at the methods. So over here on the right, we have a burette. And so a burette is used to measure the volume accurately. And usually the burette, you can measure to 2 decimal places. And then over here, we have a magnetic stirrer. And then in here, we have a magnetic stir bar that spins around by the magnetic stirrer and helps mix the solutions together. So generally in here, we'll have the acid. And then usually in the burette, we'll probably have the base. And then so let's take a look here. So the analate is the thing that you don't know the concentration of. So that's the analate that we have here in the Erlenmeyer flask. And so we want to find the concentration of that. And so what we use is we use the titrant, and the titrant is the opposite thing. So like the base, we would know the concentration of. We would know the concentration of the base. We would want to find the concentration of the analate, maybe the acid. And then what happens in titration is that we'll use a pH indicator to help us to identify when neutralization happens, and then we can use stoichiometry to help us figure out the concentration of the analate, the thing we want to analyze. And so what we're going to do is there's some key terminology here that we need to know. So the equivalence point occurs when basically the mole ratios are equal, and the moles of the acid and the moles of the base are equivalent according to the mole ratio. So if it's 1 to 1, then the moles would be equal. If it's 1 to 2, then the moles of whatever the thing is with 1 to 2, they would be equal based on double the amount of moles of one of them, depending. The endpoint is when the pH indicator changes color, because an acid and a base, they're both clear in color. So when we mix them together, we actually don't know when the equivalence point would be. So we need to know when the pH indicator changes color, and so that would be the endpoint. And then the most likely pH indicator that we use phenolphthalein, and so we add it to the analate. And so over here we have phenolphthalein, and so right here on the left side, phenolphthalein is acidic, and it's clear in this particular flask on the left. So it's always clear with a pH of 8 or below. And then at the end point, it'd be the faint pink. And then over here, when it's basic, it's this bright pink that we have here, and that's too far. So when do we stop adding the titrant to the analate? The drop that happens at the endpoint. So once we get closer to where we think the equivalence point or the endpoint would be, we would start adding the base drop by drop. Now, all along, we'll show you the procedure in a shortly what happens. Now, the reason why we could use phenolphthalein, and you're like, well, what doesn't it change at 8, 9, or 10 for pH? Yes, it does. But if you take a look at this graph, you'll see that when it neutralizes something, especially with acids and bases, for strong acid and strong base, the pH changes at a pH of 7. They're neutralized. And then a pH of 8, 9, or 10 for phenolphthalein is almost virtually the same volume of sodium hydroxide that was added. So where's the equivalence point? The equivalence point for a strong acid and strong base titration is at the pH of 7. That's when they're neutralized for a strong acid and a strong base. It's different for if I have a weak acid or a weak base. Where's the endpoint? Well, the endpoint is where the pH indicator that we chose changes color. So on this graph, phenolphthalein changes between 8.0 and 9.5 pH. And then there is no significant difference between pH of 7 and a pH of 8, 9, or 10 in terms of the volume. So that's the reason why phenolphthalein is appropriate. So let's take a look at the lab technique for titration. So if we take a look here, we would pour the acidic solution into a 50 milliliter beaker, assuming that it's clean. It's washed out with soapy water, and then the last rinse is distilled water, and then we would dry it out to make sure that the concentration of the acid is the correct concentration that we want. Now think about what happens if water is in there. Then what would happen to the acid if we put put it into a wet beaker? So now we're going to rinse a 5 milliliter volumetric pipette 3 times with it, and the volumetric pipette is over here. And so let's take a look. So we're going to dispense it, and we're going to dispense it into the Erlenmeyer flask. Now, the reason why we rinsed the acid solution in the volumetric pipette is because it could be wet inside. And then if there's water inside, what would happen to the concentration of the acid inside? Well, the concentration of the acid would be lower than what we thought it would be, and then it could affect our results. And then you would say, well, how does it affect our results? Well, that's part of the experiment that would happen sometime. All right, then once we've dispensed 5 milliliters of the acid solution into the flask, and then we can add distilled water to the flask to increase the titrating volume. It doesn't affect the amount of moles of acid because we already measured it from the volume that we dispense from the pipette. So at this point, remember, if we add the distilled water here to increase the titrating volume, it doesn't change the number of moles of acid that we dispensed from the pipette. So now we're going to add phenolphthalein in there. And so at this point, since the acid is in the solution, is in the Erlenmeyer flask, the color should be clear. And now we're going to clamp a burette clamp to the ring stand. And then what's going to happen is then we're going to clamp the burette into the burette stand just to make sure it's there. And then what we're going to do is we're going to fill it up a couple of times with a small amount of base. So we're going to rinse it with maybe 5 milliliters of base just to make sure that after we clean the burette, that the burette is actually the base, the concentration of the base that we want. And we also make sure that the tip is also rinsed too. And then once we're done, then we make sure that the stopcock down on the bottom where the little valve is closed, so it's perpendicular. And then we add the base into the burette. And then what happens is then we make sure that we take out the funnel, and then this is a waste beaker. We drain some of the base through to make sure that there are no air pockets or air bubbles in the burette tip because we don't want that counted as the volume. Now we close the stopcock and we wait, and then we read. So please take a moment to practice reading. And then we'll take a look. And then you want 2 decimal places because of what we had done. The increments are every 0.1 milliliters. So we need an additional guess digit. So if you guessed 3.78, 3.77 milliliters, 3.76, any of those could have been appropriate. Now we're going to go ahead and do the titration. So it's easier against the white background. So we put a little Kim wipe or a little piece of paper down here that's white because we want to see that faint pink. And then we keep on titrating. And as we're titrating, we want to swirl the flask to make sure that everything's mixed. And then if needed, you're going to add some distilled water, like it says here, from a wash bottle to rinse down the sides, just in case some of the base or some of the acid gets stuck to the side. We want to make sure that it all reacts down in the bottom. And then when we're close to the end point, we go drop by drop from the burette until we get that faint pink color, just like here. And then that's the end point, light pink. And then sometimes you over titrate, you go too far and you get dark pink, which is not what you want. And then we close the stopcock and then we wait. And then we make the measurements. So why don't you go ahead and practice, take a moment. All right, and let's check out what the answer was. So 18.20 milliliters, 18.21 milliliters, any of those would have been fine. And then you subtract those two numbers, the final volume minus the initial volume, and then that would get you the volume of base that we dispensed of the titrant. And then we would go ahead and then do our calculations of the neutralization reaction, and then we would solve for the concentration of the analyte. And then that's it. And that's how you do acid-base titration.